So, Shruti, the question is for you. How do
Yeah.
you secure data stored in Amazon S3? Guys, S3 is actually a space where you can store unlimited amount of data, but when the data comes, it comes with the security. It should have security, and that's what Shruti is going to help us to answer this question. Over to you, Shruti.
As I said, we have three different types of storages in AWS. One is object level storage, which is S3. And then we have block level storage, which is EBS for us. And then we have file level storage, which is EFS. So, our current question is, how are you going to secure the data which is stored in S3? So, having said that, S3 is an object level storage, right? So, here the data is going to be stored in the form of an object, and the object could be anything like your audio file, your video file, image, it could be anything. So now how are you going to protect that data? So when it comes to cloud, one of the most important things is your data and how secured we are going to keep it in our environment, in the cloud environment, right? So for that, let's divide this into three sections. The first section is going to be how are we going to properly encrypt our data and store it in the cloud. So when we talk about encryption, there are two types of encryptions. One is encryption in transit and encryption at rest. So at rest means the data has already entered your cloud premises, and how are you going to protect it properly in your premises? So whereas encryption in transit means your data is coming across internet. So as you know, since we are talking about cloud here, everything is about internet, right? You get to access things through internet. So while your data is traveling in across internet, right, how are we going to protect it? So for that, AWS is offering us like multiple types of encryption techniques that is available. So the two main things are called as, one is server side encryption and one is client side encryption. So server side encryption is nothing but all the encryption and decryption will take place in the server. So again, for that we have multiple types of encryption types which is available. One is called as server side encryption by S3 itself, which means S3 itself, the service itself is going to do the encryption and decryption, and the keys that we use, right? The encryption keys that we use. So like in a layman language, encryption is nothing but you are going to send it across the internet where not everyone can read it, right? You're going to use some characters that not everyone will know. Only authorized person who has that encryption key will be able to decrypt it, right? So now the S3 service, so server side encryption by S3, right, we call it as SSE 3. So server side encryption S3 means encryption and decryption will be done on the server side, but the keys that we have, right, the encryption keys will be completely managed by S3, which means if that key is compromised, then it is on S3, which is a very rare situation because S3 itself is a service of AWS and the keys are going to be properly managed. So when we talk about key management, it could be if you want to change the encryption keys in future, if you want to rotate it, all that will lie with S3. I mean S3. Okay. And the next type is server side encryption by KMS. So KMS is called as key management service. This is another service that is particularly used how you secure your keys in AWS environment. So this is a separate service. So AWS is offering almost 200 plus services, whereas KMS is one among it. And now what happens here is the encryption will be done on the server side, but the complete management of the keys will be done by KMS itself. Okay, so that service itself will make sure that the keys are properly rotated, if whenever it is required it is changed, and all that will be properly handled. Okay, and the third thing is server side encryption by customer, which means by us. That means the encryption and decryption is going to be done on the server side, but again the keys that are there, right, the encryption keys are completely going to be managed by us. And this is one of the type where we need to be more secured because the keys are going to be handled by you, and when you accidentally get to store these keys in any of the public repositories, it actually becomes a threat. Okay, so this is one. And then client side encryption, you have client side encryption services particularly available. We have S3 client encryption, which means that the encryption and everything will be done on the client side, and AWS is not going to do any of the like encryption process or managing keys. Everything will be done by the S3 client encryption service itself. Okay, this is one thing. So this is properly how you encrypt your data and decrypt your data. Next thing is called as, which is very important, that is, this also falls under.
Shruti, I'm so
Yes.
sorry to interrupt. Let me
Yeah,
do
yeah.
one thing. People who
Yeah.
are coming from different background, let me explain this part, okay? And then we'll
Okay.
go to the next part.
Sure, sure.
Guys, so people who are not able to understand, can I know who wants me to go back to this all the steps what was explained by Shruti? Is there anyone who wants me to go back and explain it again? Okay, anyone who wants me to go back? Let me explain it. So basically, what happens, right? When we are, let's imagine this is our cloud, okay? And this is the cloud, and you can say AWS cloud. Now the question says that when we are storing, let's say this is our data, okay? This is our data which is in the cloud, and that cloud is AWS. Now the question is, how do I secure this data which is actually in AWS? Okay. So that is the question that every interviewer wants to know, that how are you going to secure this data? Now, what actually happens, guys, that security of data happens only and only when you encrypt it. Okay. In the cyber security field or in security field, encryption always helps to secure your data. So encryption is the main thing. But how do I encrypt this data? To encrypt this data, there are keys which are important. Okay, keys which are important. And if you basically have this key, you can encrypt this data. For example, I can make this data look like this. Uh, you know, now so you're not able to understand this, right? This data is there, but you're not able to understand. So I can use this key and encrypt it or decrypt it. So now what actually happens that when we talk about encryption techniques in the cloud, the main thing is who is going to manage this particular key. If this key is managed by S3 service, then it is called as serverless encryption SSE. Okay, when the key is managed by S3 itself, because S3 is a bucket, you're keeping the data in the bucket, and that S3 in itself is managing the key. There is another service in AWS called KMS, Key Management Service. You can manage the key with the help of that as well. And third is, let's say as a customer, I provide a key. As a human, I provide a key that, hey, AWS Cloud, please don't use your key, use my key. So as a customer, I am providing the key. So I am responsible to manage the keys. Okay. So encryption always happens with the help of a key. And that key, who is going to provide that? That is being explained over here. Okay. On the other side, let's say you don't want AWS to encrypt it. Forget about that. Encryption should not be done by AWS. Forget about who is going to manage the key. Let's imagine I have the data over here. Okay. Before I upload this data in AWS, before even uploading this data on AWS, okay, let's say this is the data which I have in my laptop. Okay, this data is actually in my laptop. So this is my laptop and it is inside my laptop. Now I want to upload this particular data on AWS, on cloud, right? So what I will do, before uploading, I will encrypt it. Okay, I will encrypt it, and that is called as client-side encryption. Okay, when encryption is happening on my laptop before uploading on cloud, that is client-side encryption. Sounds good, everyone? Are you all able to understand what is serverless encryption and what is client-side encryption? Is everyone clear on this? And Akib, which one is the best? It totally depends on project to project. We think that serverless, which is managed by AWS, is the best because there's not too much of too much of management in that. Okay, and then we basically upload up it depends like us on us that where we basically yeah, it's basically server side. Absolutely,
Mm.
Omani. I'm so sorry, it's server side, it's not serverless, it's server side. I apologize. I mistakenly write server less. It's server side. Thank you for correction. Okay, it's server side encryption. That is why it is known as SSE. Okay, sounds good, everyone. Is everyone able to understand how do you secure your data? You secure with the help of encryption, and either you go with server side or client side. Got it, everyone? So Shruti, moving on with the next. Can I move on to the next part? Next question.
No, 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 no. This
Okay.
itself has three sides. So
Oh, okay.
one
Okay.
is
Okay. Okay.
encryption. Yeah. So
Okay.
first thing is encryption. So you can just list it down. First thing is encryption.
Okay.
Second is the durability of data that also comes
Durability of data. Okay. Nice.
under security. And
Okay.
third one is access control.
Access control. Okay.
Okay,
Okay.
so now
Wonderful.
we've covered encryption. I'll quickly try to complete durability and access control. So, durability, let me try to explain it with something that's happening currently. So, we all are aware of the conflicts that's happening in UAE, right, between US and Iran. So, what happened, I'm sure that most of you all must be knowing this since you're already interested in cloud security. So, the missile attacks actually happened on one of the data centers in AWS and it is completely destroyed. Now, again, that also comes under data protection. So, in this situation, what actually helped us is, so as we all know, so cloud is what happens in real life, right? So, earlier we used to have data centers for each and every organization and we used to manage it, where now our cloud service platforms are managing it centrally in one place and distributing the data globally, right? Now, if the data center is damaged, it could happen because of, like, we often say there are physical attacks also possible, right? When we talk about disasters, physical disasters are possible, and this is the best example for it. So now that physical disaster, the missile attack actually destroyed the complete AWS data center. And now that you know that all the data is kept in a data center, what will happen to the uh Naman, I hope I'm audible. Is my voice
Yeah, yeah,
breaking?
yeah, you are audible. Completely fine. Yes, yes.
Yeah. Okay. So, in that situation, how are we going to protect it? So, here comes our second category, which is durability of data. So, you need to ensure that your data is always available wherever it is. Now, that my data, which is stored in the UAE data center, is now destroyed. Now, that shouldn't end up that my data is completely destroyed. So, that's why we always have backup plans where we do something that is called as cross region replications. So this also comes under security because we need to secure our data. So my data that is originally available in UAE data center is now destroyed. So now what I do is we have replications of the data in other regions as well. So that is where we are safe now. So my data is actually available there, but a copy of it is also present in some other region. Now that region could be North California, North Virginia, Mumbai, Canada, wherever it is. So now a copy of the data is available. So anyway, even if there is a threat for my data center, still who does the replication? Good question. That also will be done by cloud security professionals. So cloud security professionals, your solutions architect, we all together do the replication process. And replication is a very mandatory thing that we do in when it comes to data, because we need to ensure that the data is available whenever whoever is trying to access it. Even if there is some downfall, we ensure that the data is available to anyone. So this is one best example that we can consider for the durability of data, which also comes under the security pillar. Okay. And the third thing is access control. So access control, so most of you all must be aware of it. We have a service that is called as IAM, which is identity and access management. So with the help of access control, you decide whom are you going to give the access for your data. We completely take that control. So we have a service called IAM, using which I will create users in my organization. I will write permissions for them, and I will tell them these people are only supposed to be using my bucket. So I will be creating a bucket. So in a company, we will be doing multiple projects, right? So for each project, we'll create multiple buckets and we store different kind of data there. So now I need to make sure that one bucket which is available should be accessible only to one set of people, right? So for that, I create proper permissions. Why I'm doing this is because always remember, when we talk about threats, it is both internal and external. So the external threats are nothing but whatever happens via middleman involvement, right? Like a hacker or a bad actor. whereas internal threats could be accidental or intentional by people who are working in our organization. So you need to ensure that you are giving the right access to the right people. So for that we are using IAM, and I restrict, even if that is a person who is working in my organization, I still ensure that only the right person is accessing the data which is present in one particular bucket. So these are the three top ways of securing the data in S3. So I hope this is clear.
Wonderful. I really appreciate, Shruti, the way you put it. So securing the data is not limited just to encryption. Durability of data is very important, and access control, that we are limiting the access. That is also very important. So thank you so much, Shruti, for putting it in a very right way.
Yeah.
Okay, so moving on, everyone. So second question is, okay, so Mona, we were just giving that information. When someone asks you question, tell them that there are three ways. One is encryption, second is durability of data, and third is identity and access management. Okay, and then so just explain briefly, because I know that you cannot take 15 minutes to answer one question or 10 minutes to answer one question. So just touch upon briefly on every part of it. Yeah, if possible with examples. Okay, over to you. The next question is, explain zero trust security and its key pillars: identity, device, and data, including how to implement it in a AWS environment. So should we try to explain this question about zero
Mm.
trust security and everything, as if
Okay.
you are answering the question in the interview?
Okay. Okay. Sure. Okay. So now what is zero trust security? So the proper definition for zero trust is always verify and never trust and always verify, which means whoever it is in my organization, I will ensure that everyone has to access things with proper authorization. So when we talk about zero trust, we have five main pillars. One is identity, device, data, network. Right, you're writing it? Yeah.
Yeah, whatever.
Identity, device,
Okay.
data, network, and applications. Okay. So these are the five main pillars for me. So when we talk about identity, I make sure that the right person with the right set of access and credentials is entering into my environment. And I always verify them regardless of in which position they are in my organization. And device, I always make sure that whichever device I'm logging in from, even if the credentials are right, I will still verify if the device is an authenticated one and if the device status is healthy. So when we talk about device status as healthy, if I work for an organization, the organization will definitely know my IP address. So my organization needs to ensure that whatever request is coming, it has to come from known IP addresses, which means known devices. Only then I will allow them to log in. If my own employee is logging in from their personal laptops, I would not allow them to log in. So that's what zero trust is. And for network, for data, I will ensure that whatever data is entering into my network, it should be properly encrypted. I will make sure there is no any kind of malwares in it. I always do a vulnerability check. I ensure that the data which is entering into my network will not corrupt any other data that I have in my premises. So I also verify the data that's going to come into my environment. And network, which is very very important. As we all know, we have certain applications that are hosted in our cloud environment, which is accessible to public. So now my requests are going to come from internet, and that could come from http or https port or tcp port, whatever it is. So I will ensure that I am not going to allow any kind of unsecured request which is coming through a unsecured network. I will make sure whatever request is coming into my environment, it has to come only from proper ports that I am allowing. Okay, so that's about network. And application, we always ensure that my applications are properly protected. I will not give access to unauthorized people, and I'll also make sure that whoever is accessing my application, they should also not do anything to my application. So I verify each and every person, device, the data that's entering my network, what through what kind of network are they coming in, and my application, I will always test if it is healthy. So this is zero trust. And for and implementing this in AWS, we use multiple services that falls under the identity category: device, data, network, and application. Using the AWS services which is available for these, I'm going to protected. But our main thing when it comes to zero trust security is that you're not going to trust anyone. Whoever it is, they need to come with proper authentication into my environment.
Wonderful, wonderful. That was quite explanatory, though. So, guys, always remember this, because this is I'm telling you with my own experience when I've met so many students. They have always mentioned that zero trust security is being applied in every organization, whether it's a medium-sized organization or a startup or a large organization. Every project wants to adapt this zero trust security. If you look at the current environment, you can find that there are so many vulnerabilities in the current environment. So that is why we need to follow strictly zero trust security. And it happens a lot that when you go in the interview, interviewers, when they are basically talking about security, they may ask you a question that what do you understand by zero trust security, and what about their pillars? So please make sure that you understand that zero trust security is never trust and always verify. And also remember these five pillars: identity, device, data, network, and application. Okay. So I hope that's clear, everyone. Moving on to the third question. How does multi-factor authentication strengthen AWS environments? So, Shruti, what happens that we hear this multi-factor authentication a lot, but
Yeah.
how is it actually strengthening the AWS environment? Because as a cloud security engineer, I might be given multiple AWS accounts. I might be given multiple services of AWS. I might be given multiple instances of AWS. How do I use multi-factor authentication to strengthen it?
Okay. So, before that, Thomas had a question on zero trust. Yes, we have an option of automating it. We have multiple pillars available and multiple security controls we'll have to do, because zero trust, we are not just giving any single loophole for someone. So we need to properly protect it. So we automate a lot of things. We have tools like Terraform and Ansible. You must be aware of it. So all of these controls, I put them across through CI/CD pipelines and Terraform, and we automate it across my entire environment. Okay, manually it is possible provided your organization size is a smaller one. If you are actually working for an MNC, for a large organization, definitely we automate things. Okay, yes. So moving on to the next question. So multi-factor authentication, I'm pretty sure all of us are aware of it, and we do it day to day, every day in our life, right? So how is it actually going to strengthen it? So first thing is, we need to know we are not just going to stick with a single password for us. So that's why we are going with multi-factor authentication. And now multi-factor authentication has become even more advanced, that we go with phishing resistant multi-factor authentication. Now what does that mean? Phishing resistant means, so normally when you want to enable a multi-factor authentication, the very common way of doing it is enabling one-time passwords, right? We get a one-time password on our contact number or our email ID, and we verify that it is us. But now what's happening is the OTPs, the one time passwords that you get, again is coming across the internet, right? Which also has a middleman involvement. So now organizations, especially when they want to go with zero trust, right? So they started implementing phishing resistant MFAs, which means we are properly going with biometric MFAs, okay? Which means my fingerprint, my face ID, my touch ID. This is the level of MFA that is going to be mandated for most of the organizations that is available. Okay. And now, how is it going to strengthen? It is really important because we also have something called as a FIDO keys, which are like hardware keys, which is very similar to a pen drive that we have, right? So you register your fingerprint on it when you are actually working for someone, and each and every time you want to work, you ensure that you insert that FIDO key, or we call it as YubiKey, the most commonly used one. So we insert that, you use your fingerprint, and then only you will be having access to all the resources or applications which is available in your environment. So mandating MFA is very important to strengthen the cloud security posture in AWS environment. So we are not going to give them a simple password or a access key. We are going to enable MFA, and double layer of MFAs are also possible. And now if you see, most of the organizations they have started doing it a mandatory thing by enabling third party authenticator tools. So, most commonly used ones, you must have heard of it. We have Microsoft Authenticator, we have Google Authenticator, and we also have Okta. So, what happens? I have a device for me, and I will download these authenticator apps in a very trusted device of mine. So, now I'm going to log in my laptop, my office laptop. When I log in, the moment I enter my user ID and password and any code that I have, immediately a notification will be sent in the authenticator app which is there on my personal device that I have chosen. Now I need to go back to that personal device that I have, pick the code or recognize that it is me using a face print or a face ID or a fingerprint. Automatically it will log me in on the laptop that I'm trying to log in. Okay, so I will have two devices here, one that is very very trustworthy and that only belongs to me. So this level of MFA is required in order to strengthen the cloud security posture in AWS.
Wonderful. So guys, you can imagine that it's not the era anymore where we just use username and the password. We have the second layer of authentication, which is important, which is MFA, multi-factor authentication. So I'm sure everyone knows about that code, what we receive. So whenever we try to log in on our bank application or different application, after entering our username and the password, we receive that OTP or one-time password or one-time code on the mobile phone. Does that happen or not, everyone? Can somebody tell me? Does it happen or not that when you enter username and the password, it asks you to enter the code which is sent to your email or your on your device, right? And the thing is, in nowadays, even that is most common and that is very risky. Okay. So there's a new thing which is coming in the market, and it's not new, it's basically old also, that phishing resistance MFA. That, because if anyone has access to your phone, can also enter the code. So that's why Touch ID, which belongs to with like your fingerprints, right? Your face verification because it's you, right? And then there are some UB keys or hardware keys, which looks like pen drive. You can use that to basically authenticate. So it's a next level security which is being adopted by the industry today. Okay, so mandating this MFA, phishing resistance MFA, is really important for every organization. And there is something called as third party authenticator tools. I'm not sure how many of you have already used this, like Authenticator, Microsoft Authenticator, or Google Authenticator or Okta Authenticator. So, for example, if you're trying to log into your laptop, you enter username and the password. Okay, and after that, you open that Authenticator app in your phone, and that Authenticator app gives you the code which changes like every 30 seconds, and you enter that code to authenticate. So this way, one of the hacker or the middleman will never be able to get into your device because that code changes every 30 seconds, right? So this is the way which is being used to strengthen security on AWS environments today. Okay, so please make sure you keep a note of it because it's going to be very helpful if you talk about it in only in this particular way. I mean, you can make some stories on top of it if you have enough time, but make sure the essence of the content is delivered to the interviewer. Okay, and that's what we are putting attention right now. It's not just about understanding the concept, it's about when you are answering the question to an interviewer, make sure every detail is covered in your answer. You should not miss anything. Okay. Okay, the next question, Shruti, for you is what is elastic load balancing and how does it improve availability?
Okay. So when we spoke about data in the previous section, we said that durability of data is also important, right? Which means availability of data is what we meant there. So you need to ensure that it is always available to everyone. Now let's talk about that in a different point of view. So elastic load balancing is one of the concepts which is available in AWS, which is used to properly distribute the traffic across multiple applications or instances. So ideally, you'll be having your applications hosted in any of your instances, right? And that could be, say, for example, I have a retail application in one of my instance. Now I want everybody across the globe to use that application. application. Now it doesn't really look good if some people are able to access my application while some are getting some error like, sorry, this application does not exist, or a blank page or some error code. That's not how an ideal application is supposed to be functioning. So how am I going to globally distribute this traffic? So what I do here is I use something that's called as an elastic load balancing, a concept. We have four different types of load balancers. One is I mean your uh, sorry, the elastic load balancers, you have four different types. One is your application load balancer, you have your network load balancer, you have gateway load balancer, and lastly you have classic load balancer. So all of these I will be using this in different layers of OSI layers. So the OSI layers, I'm pretty sure that's the basic of what we learn when we enter into network, right? So you all must be aware of it. So on which level of the OSI layer, which load balancer am I supposed to use? So, considering that I have an application and all the traffic is going to come to that application. So, in that situation, I'll be using an application load balancer. So, we can dive deep into all of these load balancer types, but we're not going to do that. But just we'll just pick one example where if my traffic is coming to all applications that I have, how am I going to use distribute the traffic? I'll be using an application load balancer there. Okay, so when through the help of this application load balancer, I am going to distribute the traffic evenly across multiple instances. For example, if I have four instances ready with me, and imagine if I didn't have a load balancer, and if I have eight people logging in at the same time, all of them might end up logging in into the same instance, and which is not what I want. Now that I have four instances, my traffic, people should be directed through all the traffic, all the instances which is available. Now, if two people are pushed into one single instance, now the traffic is evenly distributed, right? So that is what load balancer is going to do for me. So with the help of load balancer, I am going to push the traffic evenly across multiple instances with through which I make sure that my application is highly available to everyone. That's very, very important. Two main things is for high availability. First thing is high availability, and the second thing is fault tolerance. So fault tolerance in general, that's not just with cloud or AWS, it's a very general term, which means even if one component in my system is failing, how good is my entire system giving the output, right? So if my one system is failing, still my output will definitely not be 100, but it should at least be 80, 85, or 90 and above. That is what is called as fault tolerance. So to which extent is my system able to tolerate any kind of fault that is occurring, right? So when you use this load balancer, it offers you these two things. First thing is high availability of your applications, which means everybody is able to access the content of your application. That's one thing. And second thing is fault tolerance. So now say all the instances that I have, right? One instance might fail health check, which means it might become unhealthy for some reason. Either my CPU is not working properly, any issues on the storage side. For some matter, my instance, one of my instances is not healthy now. So when that instance is not healthy, I am my concern, my main thing about load balancer is it offers fault tolerance, which means the traffic is will now be sent on to the next instance rather than waiting for that original instance to become healthy. It might become healthy over time, but I'm not going to waste time there. I push the traffic into the next available instances. I ensure that even if one thing is failing, other things are able to cope up, right? So that's how I ensure that a load balancer is used. Through this is the mechanism through which it will make sure that the availability is high in my environment. So everyone should be able to access the data without any kind of interruption. So that's why I use a load balancer here. Yeah.
Okay, thank you. So, guys, it's a simple thing which Shruti actually tried explaining. For example, you have your application, okay? And so if you have only one instance of application and there are like many users who are basically reaching out to one application, it may happen that this particular application get overloaded. Can this happen or not? Let's say if one of my application is running and if I send millions of requests, can my application get overloaded or not? Let me know in the chat window. So let's say if I have one application and I'm trying to hit millions of requests on one application, will my application get overloaded or not? Right? And that happens, and that's a very, very, very common thing, right? So to address that, to address to basically manage the traffic, what we can do, we can basically distribute the traffic, or we can distribute the traffic with the help of load balancer. So I created the copy of my application, multiple copies of my application, and I placed this load balancer over here. Now, if a user one is coming here, randomly load balancer is sending it here. If user two is coming, load balancer is sending over here. If user three is coming, load balancer is sending over here. If four is coming, load balancer is sending over here. So what's happening over here? Load balancer is basically trying to understand that, you know, all the requests which are coming, the millions of requests which are coming, because there are so many application instances we have created, the replica of instances we have created, it will help to navigate all the traffic equally and evenly distributed, right? And that's why load balancer is very important. For example, let's say today you come on Thinkcloudly website. In Thinkcloudly website also has a load balancer over there. There are like 200,000 requests what we receive, right? Probably in a week time. And when we receive so much of traffic, one server cannot handle. So what we did, we basically created multiple copies of Thinkcloudly website. So when you come on Thinkcloudly website, probably you are redirected by load balancer. When another person comes, that person is also getting redirected by load balancer. Because of this, you are able to achieve high availability because your application is always available. One system is not getting overloaded and getting shut down. Like Mona is saying, it can crash. So that is not happening anymore. So high availability is achieved. Okay. And fault tolerance means if, let's say, one server has a problem, okay, then there is other instances which are available to take the load. And that is your fault tolerance. That if anything goes wrong to one instance because of load balancer, it can distribute the traffic to healthy applications only. So load balancer also performs health checks. It check whether these instances are healthy or not. If it finds that any instance is unhealthy, it's not reachable anymore, it never forward the request to that instance anymore. Are you guys getting my point? Are you guys are able to understand Shruti and me? Is everyone able to understand how the load balancer actually works and how it improvises the availability? And now you can keep any case when you are using Uber, you are trying to book your Uber, and at that time there are like so many requests coming to Uber. How they are handling it? It's handling with the help of load balancer. Okay. Moving on to the question number five. Over to you, Shruti. Which AWS services would you use for logging and monitoring security events? And that's very important. Like how are we going to log all the events and security events in AWS with the help of services?
Okay. Yeah, before that, like Thomas is having really great questions that can help a lot of people. I think we can address it after we answer this question. Configuring this, Thomas, is a huge step, right? So we are really glad to explain that. But now currently we are focusing on how to face the interviews and what kind of questions are common. So configuring it is what we completely learned throughout the course, right? So that's the next level of thing you will perform in the interview. Correct. So first you explain the concepts, and that's what we are discussing today. And ELB that we discussed is for applications. For databases, for availability, we have many other techniques like multi-AZ deployments, how backups that we have, replication. So databases are different. What we discussed is how are we going to make sure that how does load balancer contribute for availability. That's what we just discussed now. So database is different thing. Yeah, I hope I answered the question. So now, yes. So, which AWS service would you use for logging and monitoring security events? So, this question would be definitely asked in interviews, and I'll take this up like and someone who's being interviewed, Naman. So yes, so for logging and monitoring, we have two main important monitoring services in AWS, which is CloudWatch and CloudTrail. My CloudWatch is going to monitor all the metrics and logs that is available for my resources. So my the instance that I'm creating will have certain limit of CPU, disk utilization, network in and network out. Now how are we going to monitor all of this, manually monitoring this will not be humanly possible. It might take consume a lot of time. So we use tools that like CloudWatch and CloudTrail. While CloudWatch is used to monitor the resources in my environment, CloudTrail is used to monitor the users in my environment. So CloudTrail will actually tell me what each and every user is doing in my environment. That is very important because that log is also important. So purposely I create a database, I create a storage service or an application, and I give access only to certain people. Now, how will I know, or how will any auditing team in my organization know that someone unauthorized is trying to access it? So that's why we have these monitoring and logging tools which will capture that information for me. So if an unauthorized user is trying to access something and they get an error like of course they'll get an error like access is denied, but how would we know that? So in order to have proper auditing in my environment to ensure that everybody is compliant in my organization, they are all following properly according to standard frameworks and governance, I'm enabling CloudTrail, which will automatically capture all user activities in my environment. And specifically talking about security events, while CloudWatch and CloudTrail will generally contribute for all the resources that are there. For security events, we have something that's called as Security Hub, which is very very important. Security Hub is something which is a cloud security posture management tool. So we call it as CSPM, Cloud Security Posture Management. So this particular tool is going to capture all the information about security, whether when it detects any kind of a threat in my organization or any kind of vulnerabilities that has to be inspected, all of that will be done with the help of a security hub in my organization. So some organizations do use security hub, which is a native service of AWS, but then we also have some third party CSPM tools as well. So all of these are going to capture all the security events. So if I have an unauthorized user entering into my application, if there is any vulnerability in my any of my applications or tools, if I have a bad actor who has got access, if there is a threat which is detected in one of my service, all of this is going to be captured in my security hub, which is a centralized one. So while we have multiple resources, there are few security resources which will be integrated in security hub, and whatever all the other security tools are identifying will be centrally available for me in security hub. So any action that I want to take, I don't have to visit each and every account. I implement all of these controls from the security hub itself. So security hub captures all kind of security events that's occurring in my environment, and that is like monitoring everything generally, and whether I want to remediate it, whether I want to prevent it or detect any kind of thing, everything will be available for me centrally in security hub. Okay. And Naman, are you going to highlight some of the services for that matter in Security Hub?
I mean, that's good. Like so basically, so you want, so can I explain this again? Login and
Yeah, yeah,
monitor.
sure.
Okay,
Sure, sure.
sure. So, guys, for like, there are two things we are talking about. One is that how are we going to log the activities which are happening in the cloud, in the AWS cloud? Okay. For example, you are creating an instance, like a virtual machine in the cloud, or let's say your virtual machine which is running has crossed some CPU utilization, right? So all that tracking happens with the help of CloudWatch. So all the resources what you create in the cloud, you track it with the help of AWS CloudWatch. That how because CloudWatch is logging any every activity, of those services or resources. On the other side, if you want to basically see what users are doing, whether users are able to I mean, what whether users are at what time user is getting in, what services he's creating, and you have to monitor every user, because let's say in your team there are hundreds of users who are using the same AWS account, and you want to see what this guy is doing. That is done with the help of CloudTrail, so that you understand. So the people who are into GRC auditing from the governance perspective is done with the help of CloudTrail. If you are involved into cloud security part as well. Also, how do you monitor the security events? Because there are like a lot of security events which happen, right? Any hacking attempt or anything, any intrusion, right? That happens with the help of Security Hub, which is there in AWS, where it captures all the events or whatever is happening, so that you can always go back and check what went wrong, who tried getting into it, or how will you secure it for the future perspective. So this is how these three things you need to remember, because this is also one of the very important question which is being asked today.
Thank you for watching. Switch from non-IT to IT today. Explore www.thinkcloudly.com.